So you get to your exam and you're given this as a problem and you're asked how many protons, neutrons, and electrons it has. Let's figure out how to do that. So first we're going to talk about isotope notation, and then we're going to talk about ions, and this is all part of counting subatomic particles, all right? So before we get into that, real quick, just want to point out that you can check me out in any of these places over here. To support me, please give a like, follow, or subscribe and comment, and you can ask me for requests on different topics that you'd like me to post another video about, or even specific questions. And additionally, if you'd like to support me further, you can check out my Patreon and help me to continue providing free lessons like this for you guys on all these platforms, all right? So now let's get to it. So when we get a problem like this, we're looking at isotope notation. And let's just go over that real quick. So we typically use a capital E, which just stands for what element this is. Down here on the bottom left, we call that Z, which is the atomic number. Up here on the top left is A, which is like A is kind of like atomic mass, but it's really mass number is the actual term for this. And then on the top right, we have Q, and that's for the charge of whatever the element is that we're looking at, or ion. So now let's define these things. So Z, the atomic number, is just equal to the number of protons in an element. That is what defines this as an element, right? If I change this from 11 to, let's just say 10, it would no longer be sodium, that would now be neon. And so if you look at your periodic table, number 10 is neon because its atomic number is 10, right? Sodium is 11, and that is how many protons it has. So in other words, the number of protons an element has defines what element it is. So then, if you look at our mass number, this is equal to the number of protons and the number of neutrons together. Now, that may sound arbitrary, but the reason is because a proton has a mass of approximately 1 atomic mass unit. And then a neutron has approximately the same mass. So if we look at mass, oops, it's a little sloppy. I think you guys can read that, right? Mass, and then let's do charge over here. And we have protons, neutrons, and electrons. I'm just getting sloppy as I go, my apologies. The mass of a proton is going to be about 1 AMU. I'm going to say this mass is in atomic mass units. The neutron mass is about 1 AMU as well. And the electron, for the purposes of these type of problems, we round it off to 0. I think it's around like 1/1840th of the mass of a proton or neutron. But in this type of problem, we just round that off to 0 because it's so insignificant in comparison. So electron mass, I'm going to say it's approximately 0, although it does have mass. And then let's look at the charges of these subatomic particles. A proton, you can tell right from the notation, has a +1 charge. The neutron, again, from the notation, it has no charge. It's a neutron, so it's neutral. And then the electron has a -1 charge, right? And that's why we put the little minus in there. So it has a negative charge, right? So plus means the same as +1 or 1 plus. And so this little table here helps these formulas make more sense, right? So if a proton weighs 1 atomic mass unit and a neutron weighs the same, then the mass that you have is just the number of protons and neutrons together, right? So if you have 11 protons and 12 neutrons, well, that adds up to 23, and that's the mass number here, right? So mass number is protons plus neutrons, and then we have our charge. So if a species, right, an atom or an ion, well, let's say an atom in this case, is neutral, then you would have the same number of electrons as protons. Because if electrons have a negative charge and protons have a positive charge, and you have the same number of each, well, like 5 positives and 5 negatives add up to 0 charge, right? So in the case of this sodium example, we know that we have 11 protons because that is the atomic number. And so if there was no charge here, we would also have 11 electrons because that would add up to 0. but we clearly don't. We have one more positive charge than negative charge, so we have to remove an electron, right? We can't change the number of protons, right? We can't add a proton to make it more positive, because that would change what element it is, right? If we gave it 12 protons, now it would be magnesium. So we can only change the number of electrons to account for the charge. And so the formula for getting the charge, it's the number of protons minus the number of electrons, since electrons are negative. So again, if it was 11 protons minus 11 electrons, we get a 0 charge. But in this case, we have the +1, so it would be 11 protons minus 10 electrons would give me a +1, right? So these are the definitions formulaically of each of these variables. Let's write out the formulas solved for each individual particle that you're trying to get. So I'm going to get rid of this table. You guys can write that down in your notes, a bit neater than I did over here on the board. So this one, I don't know, think I really need to rewrite it, but I'll just do it anyways. Protons is equal to the atomic number. And then neutrons is going to be equal to, right, if we solve for n here, we would subtract p to the other side. So it's the mass number minus the number of protons. You could also write, instead of p plus, you could write z instead. You could do a minus z is equal to the neutrons. A lot of people write it that way. That's probably the way it's in your textbook. But and then to find the number of electrons, we would solve for electrons here, right? So if I add it to this side to make it positive, then subtract q over, it's going to be equal to the number of protons minus the charge, okay? So with this, we can say that the number of protons was 11, right? Because that's z is 11, so there we go. The number of neutrons is going to be the mass number, which is 23, minus the number of protons. So we have 23 minus 11 is equal to 12. And then the number of electrons is going to be the number of protons, and that's 11, minus, that's a positive 1, so we could just put a 1 there, right? And then that gives us 10. So that's how we solved this one. Now let's say if some things were done a little differently. So on your exam, you may actually get the problem stated like this. They may not actually give you z. So now, if you don't have z, what do, right? Because you're supposed to say, okay, well, z is the number of protons. How do I get the number of protons for this? Well, luckily, in basically every chemistry course I've ever heard of, you get a periodic table. So if you have your periodic table, you can just look. You find sodium on there somewhere. There's sodium, and it is number 11, right? And so its atomic number can either be given to you, it's either provided down here where z goes, or they may not give it to you, and you just look on your periodic table, just find the symbol, and then you know what its atomic number and its number of protons are immediately, right? Let's do a different example. Let's now go and do something with a negative charge. So let's do fluorine. I also quickly rewrote some of these formulas over here. My little table, a little neater over here for the mass and charge of each subatomic particle. And then the formulas written out for atomic number, mass number, and charge in terms of the subatomic particles, and as well as the reverse, when you're solving for the protons, neutrons, and electrons. So, you know, maybe I'll step out of the way. You guys can screenshot that. And then let's do the next example. So let's do fluorine. I'm not going to put anything down here where Z goes. And there's really only one stable isotope of fluorine, which is 19. So let's just start with this example the way I have it at this moment. So if we want the number of protons, neutrons, and electrons, well, remember that protons are equal to the atomic number. Now, I didn't give it to you, so what do we do in this case? The periodic table, right? So you just go to the periodic table, and then over there, you're going to see there's fluorine on the top right side, and it's going to have a number 9 on the top, and then a 19.00, or however many decimal points your periodic table gives you. And so on the periodic table, right, the top number is going to be the atomic number, and that's our number of protons, okay? So we immediately know from our periodic table that the number of protons and the atomic number are 9. And then let's do the neutrons. So neutrons is equal to the mass number minus the protons, right? So we have a mass number of 19, and there are 9 protons. So 19 minus 9 is 10 neutrons. And then I said we'll do something negative, but I just wanted to do quickly just fluorine itself, this isotope. So if there is no charge here, that means it's neutral, right? Now, you can just think about it logically. If it's neutral, it has to have the same number of positive things as negative things. So the same number of electrons as protons. So we know that it has to be 9, right? You need 9 negatives to cancel out 9 positives. So this is going to be 9. But if you're someone that just wants to look at the formula right away, you can just look electrons is equal to the protons, which is 9, minus the charge, which in this case, there's nothing there, so that's 0, okay? So you can just, if you want to plug it in, you can put 9 minus 0, and you'll get 9 again, okay? Now let's change the example and say that it is an anion, which means it has a negative charge. So now, the negative charge only affects the number of electrons, right? Because again, the protons is equal to the atomic number. We cannot change those. Otherwise, we're changing what element we're talking about. The neutrons, that's only affected by the mass number. So the electrons is the thing that we can change to account for the charge. So now, if when it was neutral, it had 9 electrons, and now I'm giving it a negative charge, it has to have 1 extra negative thing, or 1 extra electron. So then instead of having 9 when it was neutral, now it's going to have 10 electrons. And again, if you like the formula, electrons is equal to the protons, which is 9, minus the charge, which in this case would be 9 minus -1. And then when you subtract a negative, it's the same as adding a positive, which is 9 plus 1, right? So either way you think about it, what we're going to get here is 10, okay? So now, fluorine's really never going to have a -2 charge, but let's just pretend that this said 2 minus for a moment. Just to keep things simple, if it was 2 minus, now it has to have 2 extra electrons. And in that case, this instead of being 10, it would be 11, right? But you're really not going to see that for fluorine. And we can talk about why in a later video. So now let's go the opposite way. What if I give you the protons, neutrons, and electrons, and we want to get the isotope notation from that? So if I, oops, didn't need to erase those. Let's give you, let's see. What if I want to do 12 here? Let's do 12 here, and let's do 10. You know, something that's like a real element, or ion in this case. So 12, if you go to your periodic table, they're numbered, right? Just hydrogen, helium, right? Lithium, you just go through 3, you get to 12. That's magnesium. So now you know what element symbol to write down. It's Mg. And you can put the 12 down on the bottom left because the proton is equal to the atomic number, which goes on the bottom left. Now, how do we get the mass number? We have to fill in all these variables. So the mass number, again, is the protons plus the neutrons. So we just add those up. 12 and 12 is 24. And then we want to get the charge, which goes on the top right. And the charge is the protons minus the electrons. So 12 minus 10 is a +2. And so you can't just write 2, though. You have to write the plus. And the convention is that you put the number first, so 2, and you put the signage afterwards. So 2 plus. All right? So that is subatomic particles and isotope notation. Again, guys, if this helped, please give a like, follow, subscribe, comment, share, all those great things, and consider supporting me on Patreon. As well as you can send me a DM if you'd like to get some private tutoring lessons from me. So go ahead and feel free to reach out, and I'll see you guys in the next video.